All right, chemists. We're going to learn today about Lewis structures, and Lewis structures are an extremely useful skill that you will gain for this year as we move forward into subsequent units. You will need this skill to help you understand things like intermolecular forces and why things stick together. So if you study organic chemistry in the future, this will be something that you really want to be good at now because it'll help you understand organic chemistry. So a Lewis dot symbol, we talked about this a little bit earlier in the year. It's just a diagram that uses dots to show the valence electrons of a single atom. So by now you should know how to find valence electrons. You do that by looking at the column on the periodic table. So you have something like carbon. Well, you look at your periodic table, say, okay, carbon is in group 4, so that means it has 4 valence electrons. Now, I want you to do something a little different when you draw these 4 dots in. I don't want you just to draw 4 dots willy-nilly. I want you to imagine that there's a box around the carbon and fill in the dots one at a time around the outside. So, for example, for carbon, it's 1, 2, 3, 4. So you go one side at a time. You don't need to actually draw the box, but just one side at a time. And then we do oxygen. So oxygen has 6 valence electrons. So we go 1, 2, 3, 4, 5, 6. And the reason we do this will become clear as we move forward. Okay. So how do we put these structures together? Well, you saw from class that if we have 1 C, 1 N, and 5 H's, we can just draw them out one at a time. So let's start with the molecular formula. So this is CH5N or CnH5. However you want to write it is fine. Now the way I do this is I start with C, and I have my 4 valence electrons. I'm going to put N next. N, I'm thinking to myself, okay, it's in group 5, so that means 5 valence electrons. Again, 1 on each of the sides before I pair them up. I'm going to put hydrogen in as a different color. So I have 5 hydrogen, and each hydrogen has 1 valence electron. So your goal in making Lewis dot structures is to pair up. You don't want lonely electrons. So your first step is to pair up the ones that want to bond the most. Carbon has 4 lonely electrons. Nitrogen has 3. All of the hydrogens only have 1. So you pair up the ones that want to bond the most. So I'm going to pair up these. A valence electron from carbon and a valence electron from nitrogen. And now I count carbon has 3 lonely electrons. Nitrogen has 2. I have 5 hydrogens, so now what I can do is pair these up. Now, that looks sloppy. In fact, I can't even look at that and understand what's going on. So what we do instead is we put it all together. So that carbon and nitrogen now, I have carbon, and there are 2 electrons making a covalent bond between the carbon and nitrogen. I have the 2 dots on the top of the nitrogen that were there before. If I look at these 2 here, well, I have 2 electrons between the nitrogen and the hydrogen. Another 2 here. And then with carbon, I have 3 bonds between the carbon and 3 hydrogen atoms. So when I put it together like this, this is the Lewis structure. Lewis dot structure. This is something we're going to practice a lot. Okay, so feel free to pause if you need to copy this down, rewind if you need to see it again. We're going to be going through it a little bit more. Okay, so symbols versus structures. You can actually use the Lewis dot symbols to create Lewis dot structures. So like we did there with the carbon, the nitrogen, and the hydrogen, we put them together to build a molecule. And that Lewis dot structure is a diagram that uses dots to show the valence electrons of a molecule. So it's going to really help us understand how the atoms come together to form a molecule, similarly to the structural formulas that we learned about yesterday. Okay. Again, pause if you need to take the time to copy stuff down. So we're going to talk about two types of pairs. Remembering that a covalent bond is the sharing of a pair of electrons between two nonmetal atoms. That's the definition of a covalent bond. So in Lewis structures, we have a bonded pair. And this is a pair of electrons that are shared between the two atoms. So let's go back and we'll do our molecule that we were looking at before. So bonded pair. This is a pair of electrons shared. How many bonded pairs are present in this molecule, CnH5? Think to yourself, how many bonded pairs? That's right, there are 6 bonded pairs. So if you didn't get 6, each of these 2 electrons that connect 2 atoms in a covalent bond count as a bonded pair. So any 2 electrons that are connecting nonmetal atoms in a covalent bond are considered to be a bonded pair. Now, what about this last little pair over here? Well, this is called a lone pair, which makes sense. It's by itself. That pair is by itself. All right, so some valence electrons are not involved in bonding. So the lone pair I showed you on the molecule before, it's just a pair of valence electrons that's not involved in bonding, and they belong totally to that one atom. Now that's going to be important when we start talking about shapes. All right, wrapping this up. The question was, how does one atom bond to another in a molecule? Well, a covalent bond is a bond in which 2 atoms share a pair of valence electrons. That's something that we've known already. And these Lewis dot symbols show the valence electrons in an atom and are used to predict bonding in a molecule by building Lewis dot structures.